Hello viewers, welcome back to my YouTube channel. In this video, I am going to discuss about the authentication header protocol and the introduction to authentication header. The authentication header is a part of the Internet Protocol security suite. It provides integrity, authentication, and anti-replace services for IP packets. And the authentication header can be used in conjunction with the encapsulated security payloads (ESP) for enhanced security. And how the authentication header works is by operates by adding an authentication header to the original IP packets. It calculates a cryptographic hash of the packet content, which is included in the header. This hash value is created using a shared secret key between communicating parties. And the components of authentication header. The main component of the authentication header are the header, payloads, and the trailer. The header includes the data such as the security parameters, index, and sequence number. The trailer is used for padding and alignment to ensure proper message structures. And the authentication header structure is consists of several fields, which includes the next header and the length fields. The security parameters index identifies the security association in use, and the sequence number helps protect against repress and by numbering each packets. And the security features of authentication header provides data integrity through hashing algorithms like SHA or MD5. It authenticates the sender, ensuring that the data has not altered in transit. And the authentication header does not provide confidentiality, which is often paired with ESP. And the use case of authentication headers are it is widely used in virtual private networks for secure data transmission. It is also applicable in secure communications between routers and gateways. Organization of the authentication header for securing sensitivity data over the internet. And the limitations of authentication headers. One significant limitations of authentication header is that it does not provide encrypted for data confidentially. It can only authenticate the entire packet, not the individual fields within. And the authentication header can introduce overhead due to the added header potentially affecting performance. And the comparison with the ESP. The primary difference between authentication and ESP is that ESP provides encryption while authentication header does not. And the focus solely on authentication and integrity makes it very versatility than ESP. Both protocols can be used together for comprehensive security solutions. And for implementation of the authentication header in various operating systems, it can be implemented through networking devices, and configuration involves setting up security association and choosing appropriate algorithms. Organizations must ensure compatibility between devices for successful implementation. And the key management of authentication headers is critical for effective use of a protocol. It typically involves protocols like internet key exchange to establish shared keys. Proper key management helps prevent unauthorized access and ensures security communication. And the performance implications. The use of authentication header can introduce additional processing overhead due to hashing, and the network latency may increase as the packet size grows with the added header. Organizations should weigh the security benefits against a potential performance impact. And the authentication header in IPv4 versus IPv5. The authentication header protocol is applicable to both IPv4 and IPv6 networks. While the fundamental principles remains the same, the header structure differs slightly. IPv6 offers a more flexibility header format which can enhance authentication functionalities. And the future of authentication header protocols. The relevance of authentication header may decline with the rise of advanced encrypted protocols. However, it still plays a crucial role in legacy systems and specific security scenarios. Ongoing research may yield improvements or alternative solutions to authentication's limitations. And for the real world applications of authentication headers, many enterprises utilizes authentication headers in their secure communication system to protect sensitive data. Government agencies often implement authentication headers for classified communication, and the headers are is also found in secure file transfer protocols and email encrypted methods. And the best practices for development of authentication headers are: by organizations should conduct through risk assessments before deploying, and the regularly updating cryptographical algorithms and keys is essential for maintaining security. And proper training for network administrations on configuration can enhance security posture. And for the troubleshooting of authentication protocol, common issues with authentication header includes misconfigured security association and key management errors. And the tools like packets analyzers can help diagnose problems in AH implementation. And the continuous monitoring of network traffic can aid in identifying potential vulnerabilities. And the conclusions on authentication protocol: the authentication header protocol is crucial for maintaining data integrity, and despite its limitation, authentication header remains as an important tool to the real of network security. And the understanding authentication functionalities and applications can enhance overall cybersecurity strategies.